On this 2011 through 2022 F250 Superduty with the 6.2 gas engine, P0340 often means the PCM may not be getting a usable camshaft position sensor signal. The truck may have a hard start, a no start, rough running, or an intermittent check engine light. Broadly, this can involve the CMP sensor circuit, the connector, harness routing, signal return, power or reference voltage, electrical noise, or a sync issue. If other cam or timing-related codes are present, use them as context. But for P0340, we stay on the CMP sensor diagnostic path first. First, confirm P0340 is actually present. If the CMP sensor code is present, along with a no crank or no start complaint, the path moves straight to checking voltage or sensor resistance at the suspect CMP sensor. If the code is present and the vehicle does crank and run, start with the harness and connector inspection before doing electrical measurements. With the ignition off, inspect the CMP harness. Look for poor routing, alterations, shielding problems, or anything that could let electrical interference from another system get into the signal. Then inspect the CMP connector for damage or corrosion. If you find a real concern, repair it, clear the PCM DTCs, and repeat the self-test. If the harness and connector look clean, move on and try to make the code return. Key on, start the engine, then raise engine speed to greater than 1500 RPM for 10 seconds. Do that 3 times, then check for P0340 or the same CMP sensor code group again. If the code comes back, keep going. If it does not come back, treat the concern as intermittent or symptom-based instead of forcing a failed part. Also keep in mind that ignition issues, alternator noise, radio frequency interference, CKP sensor concerns, and cam positioning issues related to oil or VCT operation can all muddy the picture when these cam signal codes are involved. If the code returns, check the generator for excessive electrical noise. Start the engine and listen for an audible electrical noise from the generator. Then shut the ignition off. Disconnect the generator or regulator B+ connector. Restart the engine and listen again. If the noise stays steady with B+ disconnected, continue with the CMP sensor checks. If the noise changes, diagnose the generator noise concern before chasing the CMP circuit any farther. Now diagnose the suspect CMP sensor indicated by P0340. If the sensor is a 2-pin VR type, check CMP sensor resistance with the ignition off and the connector disconnected. The expected resistance is between 250 to 2000 ohms. If it is outside that range, install a new camshaft position sensor, clear the PCM DTCs, and repeat the self-test. For a powered CMP sensor, reconnect the generator or regulator B+ connector. Disconnect the CMP sensor, turn the ignition on, and check the feed. A VBPWR CMP sensor should have greater than 10.5 volts on the VBPWR circuit. A VREF CMP sensor should have between 4.5 and 5.5 volts between VREF and SIG-RTN. If the feed is correct, continue to circuit integrity testing. If it is not correct, move into the appropriate power or reference circuit diagnosis instead of condemning the sensor. Next, with the ignition off, disconnect the PCM connector and check the CMP circuits for an open. Measure the CMP circuit from the sensor connector to the PCM connector. Then measure the CMP signal return circuit from the sensor connector to the PCM connector. On the 6.2-liter V8, the signal return check uses PCM pins E47 and E91. Resistance should be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. After the open checks pass, check for shorts. Measure resistance between CMP and SIG-RTN at the CMP sensor connector, and perform the additional CMP circuit resistance checks for this circuit layout. The resistance readings should be greater than 10k ohms. If they are not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If those checks pass, turn the ignition on and check voltage at the CMP circuit at the sensor connector. Any voltage present there means repair the short to voltage, clear the PCM DTCs, and repeat the self-test. If no voltage is present, move to the operating check. Reconnect the CMP sensor connector and the PCM connector, then start the engine. Access the PCM data and monitor the sync status PID. If the engine starts and sync reads yes, go to the final DTC check. If the engine does not start or sync does not read yes, install a new camshaft position sensor, clear the PCM DTCs, and repeat the self-test. With the engine running and sync confirmed, check for DTCs again. If any DTCs are present at this point, install a new camshaft position sensor, clear the PCM DTCs, and repeat the self-test. If no DTCs are present, the system is operating correctly at this time. In that case, the original concern may have been caused by a loose or corroded connector. Clear the PCM DTCs and repeat the self-test to verify the repair and confirm the code stays gone. P0340 stays on the CMP sensor path. But if the scan also shows VCT actuator, cam timing, correlation, cold start timing, or actuator control codes, use those codes to decide whether the VCT side also needs testing. If CMP sensor codes are present, handle those first. If the VCT code group is the active concern, separate the circuit type faults from the correlation and command versus response faults. Circuit type VCT faults move into solenoid and circuit checks. Correlation faults move toward a base timing check, and response faults move into VCT operation testing. The engine should be at operating temperature before running the VCT self-test. If the VCT circuit code is not present during the first check, carry out a thorough wiggle test on the VCT harness and check again. If the code shows up during the wiggle test, continue into the VCT solenoid circuit checks. If it still does not show up, pause the diagnosis, recheck the earlier path, and do not guess at a component. For a VCT circuit fault, diagnose the suspect VCT solenoid for the current code. With the ignition off, disconnect that VCT solenoid and measure resistance across the solenoid side. The expected value is between 5 ohms and 14 ohms. If it is outside that range, install a new variable camshaft timing solenoid, clear the PCM DTCs, and repeat the self-test. If it passes, check the solenoid for internal shorts. That resistance should be greater than 10,000 ohms. If it fails, install a new variable camshaft timing solenoid, clear the PCM DTCs, and repeat the self-test. If the solenoid passes, turn the ignition on and check VPWR at the VCT solenoid connector. VPWR should be greater than 10.5 volts. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If VPWR is good, turn the ignition off, disconnect the PCM connector, and check the VCT control circuit from the VCT solenoid connector to the PCM connector. Resistance should be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If the open check passes, check the VCT circuit for a short to ground. That resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Then check for a short to voltage by turning the ignition on and measuring voltage at the VCT circuit at the solenoid connector. Any voltage present means repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, move to the PCM connector inspection and reseat check. For VCT correlation faults, do not install a new component unless this diagnostic path directs it. With the ignition off, disconnect the VCT solenoid related to the current code. Turn the ignition on, start the engine, and monitor the applicable cam timing difference PID for that bank and cam. If the difference PID stays close to 0, continue with VCT operation testing. If it does not stay close to 0, check for a base engine timing concern before going farther. On the timing correlation side, a misalignment of 1 tooth or greater is enough to matter, so treat that as a mechanical timing concern, not just an electrical one. For VCT operation faults or symptom-based VCT complaints, do not install a new component unless the test directs it. Connect any disconnected VCT solenoid connectors, start the engine, and monitor the applicable actual VCT and difference PIDs while driving the vehicle and exercising the throttle to generate VCT movement. Some vehicles need more RPM and load than others before the VCT system moves. The difference or error PID should stay close to 0, although it may briefly move away from 0 during rapid VCT movement. If actual VCT movement occurs and the difference PID stays close to zero, the concern is not duplicated at that time. Clear the PCM DTCs and repeat the self-test. If the test does not pass, use idle behavior and stored code type to decide whether to attempt debris clearing or move into the functional VCT test. For the functional VCT check, diagnose the suspect VCT solenoid. With the ignition off, disconnect the related VCT solenoid, start the engine, and record the applicable VCT PID at idle. Then use a 5-amp fused jumper wire between the VPWR side and VCT side of the solenoid connector, and record the PID again at idle. If VCT movement is 20 degrees or more, the concern is not present at that time. It may have been caused by an oil flow restriction that was removed by operating the VCT system. Clear the PCM DTCs and repeat the self-test. If it does not show 20 degrees or more, continue with the debris clearing step. To attempt clearing VCT solenoid debris, monitor the applicable VCT PID at idle. Use a 5-amp fused jumper wire and quickly connect and disconnect the jumper to the negative battery terminal at least 20 times within 20 seconds. Then, leave the jumper connected and record the PID again at idle. If VCT movement is 20 degrees or more, clear the PCM DTCs and repeat the self-test. If movement is still not there, turn the ignition off, reconnect the related VCT solenoid, and check base engine oil pressure. If there is an oil pressure concern, repair it, clear the PCM DTCs, and repeat the self-test. If oil pressure is not the concern, continue to the solenoid functional check. For the VCT solenoid functional check, keep following the directed path and do not install a component early. With the ignition off, disconnect and remove the related VCT solenoid. Use a 5-amp fused jumper wire between the VPWR side and VCT side of the solenoid connector. While holding the solenoid, quickly connect and disconnect the jumper to the negative battery terminal. If the plunger vibration can be felt and the solenoid activates, install a new VCT phaser as necessary. Clear the PCM DTCs and repeat the self-test. If the solenoid does not activate, install a new variable camshaft timing solenoid. Clear the PCM DTCs and repeat the self-test. If the VCT circuit path reaches PCM operation, disconnect all PCM connectors, inspect for pushed-out pins and corrosion, reconnect them, make sure they seat correctly, and verify whether the concern is still present. If it is still present, install a new powertrain control module. If it is gone, the system is operating correctly at this time, and the concern may have been caused by a loose or corroded connector. The clean way through P0340 is to prove the code, inspect for harness and connector problems, rule out electrical noise, verify the CMP feed or sensor resistance, then prove the signal and return circuits before judging sensor operation. If VCT or timing codes are also present, keep them in their own lane and use them to guide VCT circuit, timing, oil pressure, or command response testing. Don't skip straight to parts if the circuit has not been checked. For more diagnostic training, visit STECDiagnostics.com.